In this quick tutorial, we'll show you how to run a paired samples t-test in SPSS and interpret the results. A paired samples t-test is used to compare the means of two related groups. It's typically used when the same participants are measured twice, such as before and after a treatment or under two different conditions. In this video, we're using data from a hypothetical study testing a new treatment for asthma. It compares peak expiratory flow, or PEF, measured in liters per minute before and after treatment in the same group of asthma patients. Our goal is to find out whether there's a significant difference between the mean PEF before and after treatment. To run a paired samples t-test in SPSS, we click Analyze, then select Compare Means and Proportions, then Paired Samples t-test. This opens the Paired Samples t-test dialog box you see on screen. First, we drag and drop the first variable to the variable 1 box. That's pre-test PEF in our case. Then we drag and drop the second variable to the variable 2 box. That's post-test PEF in our example. The estimate effect size box is checked by default. We're going to leave it like that. Then we click OK. SPSS will generate our results in the output viewer. Let's take a look. First, we look at the paired samples statistics table. This shows the mean value for each condition. The pre-test mean is approximately 421 liters per minute, and the post-test mean is approximately 446 liters per minute. So the post-test mean is about 25 liters per minute higher. To find out whether this difference is statistically significant, we want to look at the paired samples test table. Here we see a t-value of minus 9.272 and a p-value, or two-tailed significance value, of less than 0.001. Since less than 0.001 is less than our alpha level of 0.05, our result is statistically significant. In other words, there was a significant difference between the peak expiratory flow scores before and after treatment. Just as a reminder, a p-value that is less than or equal to our alpha level, like 0.05 or 0.01, is statistically significant. A p-value that is greater than the alpha level we select is not statistically significant. One important note though, in a real experiment, we'd want a control group. Without one, we don't know if the treatment caused the improvement or if it is due to another factor. Now let's check Cohen's d in the paired samples effect sizes table. This tells us how big the difference between the two conditions is. We want to look at the value under point estimate. We have a Cohen's d of minus 1.466. This is considered a large effect size based on the conventional benchmarks. What matters for Cohen's d is the absolute value of d, regardless of whether it's positive or negative. A value greater than 0.8 is typically seen as large. So our results suggest that there is a strong treatment effect, a big difference in peak expiratory flow before and after treatment. Well, that's it. If you found this video helpful, don't forget to subscribe for more simple tutorials.